Next up is Javier Orraca, data scientist at HealthNet. Javier will discuss healthcare finance beyond Excel, R for automation, time series forecasting, and interactive reporting. Thanks for being with us today, Javier. Take it away.
Hi, and thanks for joining my session today. So my presentation is on healthcare finance and analytics beyond Excel. I wanted to talk about R for automation, time series forecasting, and modeling in general, as well as reporting. Just a little bit of background. My name is Javier Orraca. I spent most of my career in consulting between EY and KPMG, and then I've worked in different facets of finance, corporate finance, and forecasting at PG&E. More recently, I quit my job in 2017 to pursue more of your traditional data science. So I went back to grad school after spending 12 or 13 years in the workforce, and I now work for HealthNet. We are a health insurance company owned by Centene, which is a publicly traded company, and I'm very fortunate to have access to some of the best analytics and data science tools that are out there. I wanted to first talk about Excel's prevalence. Having sort of been in consulting for so many years and seen the different levels of maturity for analytics and finance organizations, I'd say Excel is still definitely the most used software platform for analysis, whether it's ad hoc or even just ongoing reporting that your teams might be doing. It's been around for quite a long time, 1985. So Microsoft definitely knows what they are doing when it comes to trying to provide value for, finance or healthcare professionals or people that are financial modeling. If you've used, Excel heavily since the late 90s or even the 2000s, you'll notice that the GUI has undergone significant changes. The Microsoft Excel that's on the 365 cloud that's got a lot of incredible features, just sort of expanding upon the pivot tables and visualizations that you've been able to do in the past. In general, Microsoft's cloud expansion has also gotten very advanced with Power BI for data visualizations, Azure for more of your, IT or data engineering needs. I think there's something like 200 plus products now on the Microsoft Azure store for IT and data engineering organizations. And then Microsoft's also, very prominent with VS Code, so their Virtual Studio Code. If you are a Python programmer or, C, C++, C# programmer, it's very likely that your IDE of choice or your program of choice for coding in these languages is VS Code. So Microsoft's integration to the cloud for analytics and data science has certainly kept with the times, if you will. What I'm here to talk to you today about specifically is just the advancements of open source data science programming languages that we've seen in the last few years. Python and R, these are both interpreter languages. They each have pros and cons. R historically was more for your traditional statistician and has since sort of evolved in their breadth of what can be accomplished with the language. Julia is definitely a more modern data science programming language. It itself is a compiler, so you're able to attain very fast speeds with the computations you're working with Julia, and it seems to be a growing platform or language for statisticians as well, doing heavy scenario testing or Monte Carlo simulations, very compute-intensive procedures. So for analytics and data science, RStudio, they produce the probably most widely used notebook for programming in the R programming language. What you see here is the RStudio desktop IDE. This is your integrated development environment, and it's where I spend probably 8 to 10 hours a day now. I'm working still fairly regularly in Excel. Probably 20% of my time is in Excel because most of my stakeholders still live and breathe in that platform, but most of the heavier analysis and dashboarding or web app building that I'm doing is using RStudio. The way that we're deploying the content, if you're in a finance team or a healthcare analysis team and you're using Excel heavily, it's most likely that at the end of every month you are collecting a bunch of data. Your analysts are spending up to 1, 2, maybe even 3 weeks of the month putting everything into reports and then distributing those reports through emails. That's, in my experience, that is still very common in both small and large companies. Feels like everyone is still using Excel for these purposes. And what I'm hoping you'll gain out of this presentation is seeing how you can leverage something like the R programming language to not only automate all of that data manipulation work and the automation of that, but also automating the reporting of it. So instead of distributing an Excel file to 100 individuals at the end of the month, you could just, reference a URL or a website where your end users and stakeholders could visit the content you're wanting to share. We use RStudio at HealthNet and Centene, and we also use Git-backed repositories for collaboration and code share, and then for deploying this content. RStudio Connect, that is an incredible platform. It allows for push-button deployment and really allows your teams to iterate and prototype very quickly, and also develop and deploy some very robust applications using, Plumber if you want to deploy an API, or Shiny, or R Markdown if you want to deploy interactive dashboards. This is just a high-level kind of overview of how RStudio Connect communicates with the different parties. So me as a data scientist, I would be over here programming in the RStudio IDE. I might be sourcing data from some of our servers or elements of dashboard from server. We've got data stores, so you can connect your R Markdown document or dashboard to your Oracle or Microsoft SQL Server data warehouses, and then of course your end users, they can access the content you are deploying essentially on any platform, on any device. Almost all of the content we put out is mobile ready. So for automating ETL pipelines, I just want to quickly cover tidyverse. By the time I started programming in R, it was roughly 2017. Tidyverse is an expansion of base R. I would view tidyverse almost as Excel add-on. It's a very powerful collection of small packages that allows you to really build out robust ETL pipelines in a manner that has very consistent syntax. That's important because then using the collection of packages within the tidyverse, you're able to use that consistent syntax and get some very powerful, automation strings in place. I just wanted to highlight a few of these packages. I use these specifically on a daily basis, all of them. Anything from character string mutations to dplyr for manipulation like mutations. I use tidyr for pivoting data wide and long, very similar to, Excel pivot tables, but I'm doing this with code. And then per, this is more for functional programming needs or some recursion needs that you might have, similar to Excel's circular references. So if you run into a Excel circular reference error, it's possible that you might think something is wrong. If you're a more advanced Excel user, then you might actually have a need for those types of circular references. This is just an example of what a tibble looks like. It's a modern data frame that is built using the tidyverse. So this is a very high-level example of what a table might look like, a tibble might look like in R. You see the column names at the top. You see what kind of vector it is. So these are double numeric vectors. This is a factor. So it's got some descriptive information just about the tiblet in general. This is an example of what the syntax looks like for dplyr. Dplyr is probably the most used tidyverse package for data manipulation. If your programmers are using SQL, they likely can understand what is intended here. So you're taking an object, empty cars, you're mutating it across a few columns or variables, and then you're applying a case one function to it. So if there is an item within one of these columns that has a value less than or equal to 1, assign it the name low, and so forth. So it's the nice part about tidyverse and the consistent syntax I was referring to is that it's also very legible. And then we get into modeling. So for more advanced modeling, you're probably in Excel, you are probably using something like the data analysis add-on or Power Query or Power Pivot, something that improves the capabilities of base Excel, if you will. These are all very common packages that are used for both time series forecasting and modeling within the R programming language. Fable, if I'm doing a quick forecast for a time series, a date-ordered data set, I would definitely use or start off with something like Fable because it's just so easy. And in a few lines of code, you can train an auto-regressing model and forecast out, 2 weeks or 2 years. And then tidy models in general, similar to tidyverse, it introduces a lot of packages specifically for modeling. So linear and nonlinear regression modeling, and allows you to really iterate on what it is you're trying to predict for and very easily tune your hyperparameters for all the different algorithms you might be using, whether it's, Ranger for a random forest or XGBoost or some other popular algorithm. In model time, I'll talk about that in a bit, but that's a very advanced package for time series forecasting that's also available to R. Again, this is just some sample code here to show you how easy it is to tap into these advanced algorithms. This is, if you're forecasting in Excel, just 1 or 2 lines of code here can train and fit a exponential smoothing model or an ARIMA model, and just using the syntax forecast, you can indicate how long or how far into the future you want to predict. And then you're able to sort of plot the various modeling methods, the training models, you're able to plot what those forecasts look like and really get to some unique and advanced sort of insights very quickly. So model time, this is another package for time series forecasting, very advanced, but Matt Dancho at Business Science created this package, and he's really done a great job creating an ecosystem that not only allows you to iterate on your time series forecasting, it allows you to stack the models or develop an ensemble model, which is sort of an average of the different algorithms you're training, and then you could plot that all out to see how it looks relative to historical data. So typically the process that I use, as well as other R programmers for modeling, this is something that I do very often at HealthNet. We've got the overall workflow. You're pre-processing, so you're splitting the data between your test and training sets. You're using something like recipes to develop a pre-processing blueprint. You're then training your algorithms or models using the Parsnip package, and then validating and evaluating the performance of that training set using the Yardstick package. And again, this is just some high-level syntax of what tidy modeling might look like. I wanted to point this out specifically because this leverages the Use Models package. The Use Models package prepares it. All you have to type are these 4 lines of code, and Use Models will spit out some pre-populated, generated code snippets for using the GLMNet algorithm within the Tidy Models framework. So if you're new to Tidy Models, you've heard of it, but you don't really know where to get started, Use Models is an excellent way to go from 0 to like 75% very quickly, because it's pretty much giving you the code snippets for your model, recipes, the model specifications, and some additional parameters. So taking that all together and then thinking about reporting, sort of replacing that process that you may have right now. Your analysts are crunching figures, pulling data from different databases, using Excel or SQL, and then distributing your Excel reports. that's, again, a very common process. But to take it to the next level, something like R Markdown, it's very beneficial. You pretty much have code chunks and then text chunks. And when you render this, what you render is a very, text-rich, formatted HTML document. And you're able to sort of deploy what you see on the left side here and have it update at a certain cadence. So you could deploy this HTML result to a website and just point your users to that. Like anything, like Excel, the more time you put into formatting an Excel file, the richer that, end result is going to look like. R Markdown is no different. As you start incorporating, additional styling elements to your R Markdown, you can really start getting some very professional enterprise-grade reports with, floating table of contents on the left, some rich text with data outputs on the right, and again, this could all be deployed into a website. And R Markdown is super versatile as well. I just took a few snapshots of my website, but this entire website is built using R and Markdown. So R Markdown with an additional package called the distill package. And similar to the code that we just saw, the R Markdown code, this entire website is built using that, rendered as HTML using the distill package. So it's very versatile. If you wanted to build a website for your organization or your company, maybe you want to have an R User Group for your company, I definitely recommend looking into Distill or leveraging some of these resources. And then kind of moving to the next level of reporting, you've got Shiny. Shiny is incredibly powerful. It allows you to develop web applications where you have sort of a UI component communicating with a server component, and things are being rendered live, computed live, and so you're able to develop these very fast, reporting interactive dashboards that can again be customized however you need. So again, similar to the R Markdowns or an Excel file, the more time you invest into coding the aesthetics of the Shiny dashboard, the richer the content will look. You can essentially build full-on websites that are built using Shiny, but have that server UI communication protocol, so you can really develop some rich content in the form of websites. And again, this is by Absalon. They make some incredible R Shiny, demos. They make some packages for R users, so there's a lot you can do. This is a Blog Explorer website built completely in Shiny. Incredible stuff you could do with Shiny. And then lastly, just talking about how to deploy this content. Most organizations using best practices for code share and collaboration are using some type of get-backed method. They're likely using GitHub or GitLab for that type of process. We use GitLab at work, but what it allows me to do is it allows me to store my scripts and all the underlying elements into a Git bucket, a Git repository, and then I connect RStudio Connect, where I deploy everything, to that Git bucket. Like I said earlier, when you're deploying R Markdowns to RStudio Connect, you can schedule the cadence at which you want that R Markdown report to be updated. And when it comes to deploying Shiny content on Connect, you can really start incorporating some features that a lot of your other stakeholders would really appreciate. So this is just a minor nuance, but having this download button, sending your stakeholders to a website is one thing. Allowing them to download that data in different forms in Excel really makes them feel like they can take what you've built and then do their own ad hoc analyses. So we've seen a lot of positive feedback using those features. And you could even use Shiny for data entry or live data manipulation. You could use some server-side processing for that, where you're just clicking on a table within Shiny and making live edits to the data there if you need to make some kind of finance or actuarial top-level adjustment. And this is my last point. It's getting easier and easier to collaborate across languages with the RStudio environment. and RStudio Connect, we leverage the Reticulate package at work that allows, in the same exact script, for Python users and R users to pretty much code together within the same script or module. So it's very interesting what's happening these days with, collaboration across languages. And that's all I have for you. So thank you for attending my presentation. I plan on putting some additional notes on my website. And, thank you to the sponsors for the Data Summit, the Data Point Summit. And if you have any questions, please let me know. Thank you so much.
Awesome. Thank you so much, Javier. That was definitely a very insightful chat. I know we have a couple of questions that have come in for you. The first one I have here is, do you find R to be more usable in the space that you're in versus Python? And if you do, why?
Thank you. So I really think it depends on the function of your team and the work that you were doing, and also your background. I mean, I would wholeheartedly say there is not one language that's better than another for these things, and a lot of times it boils down to, what is your preference, or what is your team's preference that hired for. If my personal opinion, if you come from a heavy Excel background without a CS degree, the R syntax and kind of functional programming style might feel a lot more similar to Excel, programming, or Excel, like writing statements. Come from a heavy CS background, I think Python will feel a bit more natural for you. And, I tend to find a lot of statisticians that prefer R, whereas you have a lot of, data engineers or back-end data science engineering teams that have a preference to Python. But again, in both languages, we're finding ways to collaborate more easily together within the same project. So, I think it really boils down to what is your preference.
Very cool. And then we have time for one more really quick one. We just got in, asking if you have any tools that you recommend specifically for Excel and Python usage.
I recommend for that. I have read about this. I have not tried it, but for the integration of Python or even R with Excel, I believe if you have Microsoft Azure and you have some of their machine learning products that are sort of like Azure add-on, fairly powerful Azure add-ons for Excel that allow you to exploit, your own Python or R pre-trained models in the back end. But again, I have not used this feature, so I can't really speak too intelligently about it.
No, that still sounds pretty great, though. Well, that is about all we have time for today, but I definitely want to thank you again, for giving us this talk. It was definitely really insightful. And everyone, be sure to head on over to our next talk. It's going to be by Grid Dynamics' own Ilya Katsov, and we'll be sure to see you all there. Thank you again, Javier.
Thank you.